Hi guys, and welcome to this video. This video is just going to be a short introduction into the ventricular system of the brain, and hopefully just helps you identify some of the ventricles in relation to some of the other structures located in the brain. So to get started, really, the ventricular system and what it does is it functions as a production site through the ventricle's respective choroid plexuses to produce cerebral spinal fluid, also known as CSF, which is just this clear and watery fluid that provides this cushioning effect for the brain, but also whilst able to help circulate nutrients as well as remove waste from the brain. Roughly, the ventricles make about 500 mil per day of this CSF through the respective choroid plexus of the ventricles, and so you can therefore respect the importance of such structures. So, in an attempt to identify them, I think the best method to do so is to try and attempt to look at surrounding features and where the ventricles are in relation to those. So starting off with the biggest ventricle, the lateral ventricle. The lateral ventricle is located here, and like I said, it is the largest ventricle, and I think what's important to note is that it is almost in line with the corpus callosum. You can see the corpus callosum running here back through from the occipital lobe, running through until the frontal lobe where it hits here and curves down as this horse-shaped like structure. And you can see if I were to put this in line on a mid-sagittal section, you could see that the lateral ventricle actually forms quite nicely with the corpus callosum. You can see it follows this rough shape heading from the occipital lobe and then towards the frontal lobe. And then it kind of pushes its way down through this septum pellucidum area, if you were to notice that being located a bit behind it. So that there would be my lateral ventricle. Now I won't go through the specific horns of the lateral ventricle or any of the features of the ventricles themselves, but really this is just a introduction into the basic ventricles themselves. So moving on from that, our lateral ventricle, we then have this small structure here which connects the lateral to the third, and this structure here is called our foramen of Monro, and really all this does is, like I said, it is just a drainage site for the CSF running through the lateral ventricle and then down through the foramen of Monro and into the third ventricle. Now the third ventricle is quite easy to identify, and the reason that is because it has this hole in the middle. And as soon as you see that hole, you can kind of just automatically assume that that therefore would be the area of the third ventricle. Another good way to identify the third ventricle is to also note that it is in line here with the thalamus. The thalamus. A lot of people get confused on the location of the third ventricle, assuming that it's located a little inferior to the thalamus, but that's actually incorrect. It's located on the thalamus here, which you can see on either side, and it has this hole, so there's two very clear ways in able to identify it. So moving on from that, we then make our way down where it forms this connection into our next ventricle. This ventricle here is our fourth ventricle, and this pipe that runs through, which drains from the third to the fourth, is called our our cerebral aqueduct. Now our cerebral aqueduct runs from the third, comes all the way down, and then hits into the fourth. The fourth here is located just anterior to the cerebellum and a little posterior to the pons, as well as the superior aspect of the medulla as well. So we have the fourth ventricle, and now you can notice two small projections. Not this one here, we'll disregard this one, but I mean this one and this one. And these two here are our foramen of Luschka and our foramen of Magendie, which respectively drain into their corresponding areas so that CSF can circulate. And then following on through there, we then have the central canal where the CSF also drains, and probably most importantly, drains into the central canal and then down through our spinal cord as well. I hope that helped, guys, and thank you.